I'd like to welcome everybody to this part of the program and introduce Patrick Andre, a longtime friend of AE Techron, someone that if you've sold the CIS 25 prior to now, you will have had some of his services available to your customers. Patrick is someone who sits on the DO-160 Standards Committee and is someone who also includes Boeing as one of his clients. So he does consulting there. We've asked him to talk with us about the DO-160 standard in particular and how it differs, the aviation testing differs from other testing like either industrial or automotive, where you typically need to go to a test facility. So welcome, Patrick. And could you talk a little bit about how these requirements, test requirements, are different?
Well, sure. Thanks for having me, Larry. The first thing that is important about DO-160 to know is that it is a standard that allows you to self-declare. In other words, you can perform all of your own testing at your own facility. You don't need to go to a certified testing laboratory or have accredited testing performed. This makes the ability to do testing in-house very valuable. There's many companies that I know who they own their own equipment, they qualify their own equipment for aircraft use, and the nice thing about the type of equipment that AE Techron carries is that it is performed, the testing it performs is what we call bench testing.
Mhm.
This is testing that does not require a chamber or a very expensive anechoic room or anything of that nature, but can be performed on a simple conductive bench. These benches, they have certain dimensions. They're supposed to be 2¼ square meters or larger. Essentially, a 4x8 or a 3x10 sheet of metal can be used as a ground plane for these tests. And as a result, a lot of testing can be performed just in a basic engineering laboratory, developmental type laboratory, and done quickly, easily, and on site without the use of any very fancy equipment beyond the AE Techron system.
What would be the benefit to the customer of having it on site versus going to a facility?
There is a lot of advantages to doing this. Not only is it the expense of a laboratory that tends to go away. That expense is pretty easy to capture. But some of the other aspects are that testing in-house keeps the engineer, the technician, the people of that nature in-house, and so you eliminate travel time, you eliminate time out of house where the person is not available to answer questions or maybe available for
Mhm.
other reasons, say in meetings or whatever. But there's also issues of when there is a problem during testing. If there's a field failure out of the testing laboratory, that tends to create issues for the engineer or the technician performing the test. Do they have the right parts to fix it? Do they have the right tools? Sometimes they need specialized tools to open up a unit. Do they have the engineering resources that are required? Things like maybe the design engineer being
Mhm.
available to help look at where the problem may have occurred, schematics, parts, and other engineering support. All of those
Mhm.
things are now unavailable at a testing laboratory, but are available at the customer's location, the
Mhm.
manufacturer's location. Well, now you've got an ability to perform the testing very quickly, resolve problems easily because
Mhm.
everything is there. And as a result, a lot of people will end up doing engineering work earlier on in the design and design in these fixes prior to going to a testing laboratory or prior to doing final testing.
Mhm.
They say that if you can design in an EMI fix, it's 1/100th of the cost of catching it during testing, final testing. And every time you delay one step in the process,
Mhm.
the cost of fixing EMI problems tends to go up by a factor of 100. And this is really true in a case of military and aerospace type testing,
Yeah.
especially aerospace testing, where if you do have to do a recall off an aircraft, now you're
Mhm.
looking at potentially millions of dollars of cost in order to fix a problem that you should have caught that's only going to cost a few cents during design.
Who all would be candidates for this kind of equipment? Anyone that's making electronics for an aircraft?
Anyone that has to have any type of testing performed, bench testing or EMI testing performed on their equipment prior to being installed on the aircraft, these are the people that are going to be able to use this type of equipment, your system,
Mhm.
and that type of work will pay for itself quickly because they will have to perform the test at one point or another.
Mhm.
Doing it early, doing it in-house, all of these things are going to save them a lot of money.
When I introduced you, I mentioned that you were on the standards committee.
Right.
And there's been rumor that the DO-160 is due for revision.
Yes.
Is there anything officially or unofficially that you can share with us about the changes that are coming?
Sure. Sure. Um, I am on the SC 135 committee that is updating the DO 160. We are looking for release of DO 160H in December of 2025. I think we're pretty much on track to being able to do that. There are going to be a lot of changes. However, none of the changes will impact how the equipment is going to be used or set up. In fact, there's one test, the chattering relay test from section 19 of DO 160, that they wanted to eliminate and use another type of equipment. And I was able to convince them, based on the equipment you sell and on some other testing I had done in part of the development of that equipment, to show that this is still a very valuable test and we have left it in. They have now opened up the standard quite a bit to say this is what the waveform should look like, and your equipment meets that waveform perfectly. And as long as that equipment is used, you're going to be able to perform the test. So this upcoming standard is not none of this equipment is going to be out of date as a result of the upcoming standard. And I should also mention that there is a mill standard 461H coming out.
Mhm.
And this equipment is useful for CS 101. And that test will not be changing. So again, in mill standard 461H, this the future of this equipment is still there. It's not going to go out of date.
Is there anything else that you would like to share or you think it would be important for somebody uh, working with this equipment to know?
I have found that the flexibility of this equipment and
Mhm.
the ease of how it can be, the tests can be modified and updated to maybe specific requirements a customer maybe have imposed on them. The ability to make these changes is very simple. The equipment's easy to use. The transformers that are have been designed for this system are excellent. I'm very impressed with how well they work, over what range they work, what sort of levels I can get out of them. I've been very, very happy with the performance of this whole system. And like I say, the easy use has been remarkable. And I commend you for the quality of the work you've done.
So, Patrick, you talked about bench testing and not requiring a chamber. You had shared some pictures with us. Could you kind of talk us through these pictures as to what we're seeing?
This is a good picture from one of the first people who bought this system. This particular company did rack the equipment, which you can see in the front of the image here. In the background, you see their test bench. Their test bench is about, I believe it's 30 inches wide by
Hmm.
10 or 12 feet long. So
Hmm.
it meets the requirements of the bench test, but it's out in the middle of the engineering laboratory. You'll notice that their production facility is actually in the background, and on the left-hand side, you will see their chamber. So they have a full anechoic chamber, but this particular bench and where they're performing these tests are not in the chamber. So now they can perform two tests at the same time, as it turns out, because now they can do a section 16, 18, or 19 test here on the bench
Hmm.
and still perform other testing inside their very expensive shielded enclosure, and it doesn't impact either test. As a result, both can be done simultaneously, and it's a very efficient way to maintain the flow of testing.
So, Patrick, I received a printout, an oscilloscope measure, observation of
Mhm,
a piece of equipment that's used for aviation testing. And
mhm.
you had sent me a similar image from our equipment.
Right.
Could you speak a little bit to the quality of the test signal and how important that is for a valid test?
Well, a lot of the methodologies used by some of the power supply manufacturers to perform these waveforms is that they'll chop these things up and into small little bits. And instead of having a nice, smooth transition from one point to another, you end up with these rather ragged lines that you see on the screen here. It's maybe some overshoot, like the very bottom of the as it reached the bottom of the waveform, it kind of overshot a little bit, and then again another stair step coming back up. The whole thing is a little bit noisy. It's not a clean way to do it. The beauty of the Techron system, the AE Techron system, is that these waveforms are very precise and very clean. If you see the screen capture I've got from your system here, it's coming in at 28 volts and it has a very clean ramp down to the minimum voltage. 0 volts goes across, and very clean and precise ramp up. This has been typical of every waveform I have generated out of this system. I went to another client who uses AE Techron amplifiers, but has their own digitizing
Hmm.
waveforms that they put into the amplifier. And it looks somewhat similar to the image from the power supply, because that digitizing waveform stair steps those signals down and
Hmm.
doesn't create a nice ramp. The 3110 has these beautiful ramps. They're very clean, they're very precise, and they produce wonderful waveforms that are going to be well accepted by
Hmm.
any customers, the people who are going to be buying this equipment.
Hmm.
They're going to look at these waveforms and they're going to say, this is the type of testing we're looking for.
So, even though it's self-declared,
Mhm.
if you are providing equipment to someone like a Boeing or an Airbus,
Yeah.
they'll want to see your test results.
Oh yeah. You need to report exactly the way you do these tests. You need to show what are the waveforms we are creating. And you need to prove that when this testing was done, it was not only done correctly, but the better quality that work is done, the more likely the customer is going to say, this looks great. Well,
Hmm.
we accept your data with no questions asked.